Today we're going to do a little two-stepping. I'm working with some inequalities too. So, two-step equations and inequalities. We're looking at the idea of balancing an equation to solve for the variable. So how do we move things, how do we rearrange things to get our variable alone so that we can have an answer for that x, or in this case x, right? The variable is a variable. So we want to solve for x. So how do we get x alone on one side and everything else on the right side? All right, to do this, you're going to do a couple of different things. Here we go. Where we start usually is with taking our terms in the simplest degrees to the more advanced degrees. So we have two terms. We have 2x, so that's kind of a multiplication, and we have a plus 5. Of these two terms, the simpler of them is the plus 5. So let's balance that side first. So to balance it, if I want to get rid of the 5 on this side, I'm going to subtract it. So if I subtract 5 from the left side of the equation, I also need to subtract 5 from the right side of the equation. So in the end, I get 2x plus 5 minus 5 is going to leave me with 2x, and 35 minus 5 leaves me with 30. Now, to get x alone, we need to now eliminate the 2. The 2, of course, is 2 times x. So we're going to do the opposite operation. Instead of timesing by x, we're going to divide by 2. And so our 2 divided by 2 is going to become a 1. And 1 times x, of course, is x. But if I do it to one side, I have to do it to the other side. So if I divide by 2 on the left side, I have to divide by 2 on the right side. So 30 divided by 2. And 30 divided by 2 in the end becomes 15. So x equals 15. Then, as we learned in previous lessons, to double check our work, we just have to plug it back in. So 2 times 15 plus 5 should equal 35. So 2 times 15 is 30, plus 5, that definitely equals 35. And so we would say yes, x equals 15. All right, so I threw some decimals in there. So you got to think a little bit differently because you got to remember how to work with decimals. But then in the end, balance it to solve it. Go ahead and try this sample question. All right, just to reinforce this idea, we're going to do one together. We're going to do the fractional one together as we work with this idea. So we have 2/3 x minus 1/2 equals 1/3. Once again, I'm going to start with a simpler concept, right? This is a 2/3 times an x, so that's a little bit more complex. So I'm going to start with my minus 1/2. So to get rid of this minus 1/2, I need to add 1/2. Minus 1/2 plus a 1/2 is going to equal 0. But if I do it to one side, I have to do it to the other. So now I have this idea, 1/3 plus 1/2. Of course, 1/3 can't be added to 1/2 because they have different denominators. So now I need to find a common denominator. And of course, that common denominator is going to end up being 6. So 2/3 is equal to 1/3, just like 3/6 is equal to 1/2. And so in the end, I come away with this new idea. Negative 2/3 x equals 5/6. From here then, I want to get that negative 2/3 away from the x. And so since I'm multiplying a negative 2/3 times x, I'm going to divide by negative 2/3 x. But of course, to divide by a fraction means I'm going to multiply by its reciprocal. So I'm really doing this. Negative 3/2 times negative 2/3. Now negative 3/2 times negative 2/3 is going to give me an answer of 1, and 1 times x is x. But since I did this to one side, I also must do it to the other side. bringing that negative with it. I can't forget that. So now I have negative 3 halves times 5 6. Now I can just kind of ignore the symbols for a minute. If I were to do absolute values of 5 6 would be 5 6 and 3 halves. So multiplying them together, absolute values doesn't really do anything. It's just multiply them together. That's what I should just say. Just say multiply them together. 5 6 times 3 halves. 5 6 times 3 halves gives me 15 twelfths for an answer. 15 twelfths then can be simplified to 1 and 3 twelfths, or 1 and 1/4. But because I multiplied opposites, that's a positive times a negative, my answer is going to end up negative. So x equals negative 1 and 1/4. So what happens when that equal sign goes away, and now we're dealing with a greater than, less than, greater than equal sign as such. Our inequalities aren't really going to change things other than how you might graph a problem like this in the end because of how graphing inequalities looks. Now, there are a couple different ideas we can look at. I got interrupted. I'll be honest, I'm not exactly what I just said. Let's just rewind a couple seconds. The inequality at this moment, we're not going to worry about it. There is one case where if you're dividing by a negative number, you do have to do something special. But that's not really going to come up quite yet in this. We're mostly going to be dealing with dividing by positives and multiplying by positives. So for now, let's just talk about the process again. We're going to balance things just like we have been doing. And to balance things, what we got to remember is that we're not dealing with an equals anymore. We're dealing with a, in this case, a greater than equal to. But our process is basically the same. Since we have a 2x and a -5, let's start with the simpler term, which would be this, and to eliminate it, we're going to add 5. If I add 5 to the left side, I have to add 5 to the right side. So in the end, I come away with 2x is greater than 6. Okay, well, with that in mind, then, we can then continue to solve. To continue to solve this inequality, we now need to get rid of this 2, so we're going to divide by 2 on this side, which means we need to divide by 2 on this side. 2 divided by 2 becomes 1, and 1 times x is x. Since we didn't have any negatives, our symbol is going to stay the same, and 6 divided by 2 becomes 3. And in the end, we have x is greater than or equal to 3, which we could then throw on a number line. And we could say, okay, here's 0, and 1, 2, 3. It's greater than or equal to, so we're going to include the 3, and then we would draw a line with an arrow going that way because it's going to be every value greater than 3. So we have that idea. All right, you have a sample then to solve. And yes, there is a negative here, but to solve it the way that we have always dealt with it, because you can see here that this is a positive 3, so you're not dividing by any negatives. So there aren't any special rules because you're not actually dividing by a negative. All right, go ahead and solve this, and I want you also graph the inequality once you are completed. All right, that's it for lesson 93.